So last section in this unit on solving equations, and the I can statement for this section is I can solve equations in context. And we've used that word before, but as a warm-up and as a reminder, we're going to read this statement right here and figure out which word sounds least familiar and then take a guess at what it means. So it says political signs are so ubiquitous at this time of year you can't go anywhere without seeing them. So clearly I would hope for everybody this is the most unfamiliar word in here. The word is ubiquitous. And from the context or from the setting of the way that's used in the sentence, can you figure out what ubiquitous means? Well, if you haven't heard that word before, this will come up occasionally. The word ubiquitous means it's very common, it's frequent, you see the signs everywhere, things like that. Okay, so when something's ubiquitous, it's just all over the place, and that's what happens during political season and stuff like that. So if we can figure out words, the meaning of words in the context of how they're used and the setting in which they're used, we're going to do the same thing with math here, and this is where this becomes really useful. So math becomes extremely useful when we can use it to solve real-world problems. So in order to use math this way, we need to figure out how the math works in the context of the problem. So this often involves using a variable to represent whatever the unknown quantity is, and then writing an equation or sometimes an expression that represents the situation. And then once we have an equation, we can solve it to find the solution or the answer to the problem. Now I'm going to warn you, on some of these problems, you may look at it, read it, and say, oh, I know what the answer is. We're not just interested in what the answer is. In fact, the most important thing as you're doing these problems is probably being able to translate what we have here in a story problem or an equation in context, actually translating the words into an actual equation. So I've got one that's kind of done for you here. So I'm going to run through and read it and then look at the equation and then look at how we figure out what the answer is. And again, some of you might know what the answer is just by reading this. So it says Tess spent $13 on one magazine and some erasers. If the magazine cost $3 and each eraser cost $5, how many erasers did she buy? And we can use this equation in order to find the answer to the question. So it's 3 plus 5x equals 13. So the question here is, what does the x represent? And this is what we really need to be good at. This is where math becomes useful. If we can take the math, take an equation, and figure out how to apply that to a real-world problem, especially on something as simple as this, we're going to be better able to solve really complex problems down the road. So let's think about this. The first question is, what does the x represent? Well, in the problem right here, it said she spent $13 on a magazine and some erasers. The magazine was $3 and the erasers were $5 each. How many erasers did she buy? Well, this is what we don't know. We don't know how many erasers she bought. So x represents the number of erasers. Number of erasers. And then it says, what does each part of the equation represent? Well, let's see. 3 plus 5x equals 13. So 13 is how much she spent altogether. So we'll write total spent on this. The magazine costs $3. So that $3 is the cost of the magazine. And then 5x. Let's see. Each eraser cost $5. So that 5 right there represents the cost of an eraser. And this is the number of erasers. So this represents the cost of, and I'm going to say it this way, the cost of x erasers. So she bought one magazine, it cost $3. She bought, we don't know how many erasers she bought, but we would multiply how much they were each times how many erasers we had, and then in total she spent $13. Now, if you've been thinking, you probably already know what the answer is here, but again, that is not the most important thing. The important part is, can we translate a story problem into an equation and then use that equation to solve? So let's go ahead and solve this. This is just a two-step problem, so we're going to subtract 3 from both sides. That leaves us with 5x equals 10. Then we're going to divide by 5 on both sides, so we get x equals 2. Now, this is the number answer that we get from the equation, but the question wasn't about a number. It said, how many erasers did she buy? So we would say 2 erasers. So we kind of put that in the context of the problem. So this is the type of thing that we'd want to see, but from now on you're not going to be given the equation and be asked to figure out what the parts are. You're going to need to figure out what the equation is. So there are a couple things, and I've got each one of these in bold, and I've got asterisks. Okay, most story problems end with a question, and that question usually tells you what you're trying to find. It tells you what the missing piece is. It's wise to choose a variable, in other words, a letter that reminds you of what you're trying to find. So in this problem, we were trying to find the number of erasers. It might have been a good idea to use an E for erasers. If we're trying to find how many buses or how many candy bars, it might be good to use a B for buses or C for candy bar or something like that. And then this is the real important point right here. Okay? The point of this lesson is not to get the answer in your head. If you can get the answer in your head, that's awesome, but this is the real point. The real point is to be able to write an equation that you can solve to get the solution. And if that's the same one as you got in your head, then you know you're doing it the right way. And a lot of times I'll run into people who can solve these in their head, but they can't for the life of them write down or tell you how they solved it. They just know they got the right answer. And that's not a good situation, because we want to be able to represent relatively simple problems like this as equations and then be able to solve them. So here's example number 2. So Molly had some candy to give her 5 children. She first took 2 pieces of candy for herself and then evenly divided them among the rest of her children. Each child received 4 pieces. How many did she start with? So Molly had some candy to give to her 5 children. She's got 5 kids. She's going to give them some candy. She first took 2 pieces for herself and then evenly divided them among her children. Each child received 4 pieces. How many pieces did she start with? All right, so how many pieces of candy did she start with? So what variables should we use, and what's it going to represent? Well, we're talking about the number of pieces of candy, so we're going to say C equals candy. And I'll even say pieces of So this problem is talking about candy, so let's use C for candy. So we're going to say C equals pieces of candy, and we could be really specific to start with. Okay? And then it says write an equation that represents the problem. Now this really is the key issue that we're dealing with today. So let's think about it this way. She had some candy to give to her 5 children. So she had some candy. We don't know how much candy she had, so let's say C is what she started with, and let's see what she did first. First, she took 2 pieces for herself. So the first thing she did is she grabbed 2 pieces for herself. Wanted to make sure she had a little bit. So we're going to take that number of pieces of candy, and if she took 2 pieces for herself, she held out 2 pieces, or she subtracted 2 pieces from how many there were. And then she evenly divided the rest of them, what was left, so here's what's left, among her children, and she's got 5 children. So if this is how many pieces of candy are left, and we're going to divide that evenly among 5 children, all we do is we just divide that by 5. So if she's got 30 pieces left, each one gets 6 when we divide it by 5. If she's got 50 pieces left, then each one gets 10 pieces. But it didn't say that. It said each child received 4 pieces, so this was equal to 4. So we've declared our variable. We've said that with the variable equals. This equation represents what happened in the situation. She had some candy. She took 2 pieces for herself. Then she divided it among her 5 children, and each one got 4. And then we're just going to go ahead and solve this. Okay, so I'm going to circle this as a big part of being able to do this. That's really the key there. And then we're going to go ahead and solve, and I'm going to change colors to solve this. So I'm going to multiply this side by 5 and this side by 5. So we're going to end up with C minus 2 equals 20. And then we're going to add 2 and add 2, so we get C equals 22. So another big piece, C equals 22, but remember C stands for candy. So the answer to the problem, and as far as stating the solution goes in the context of the problem, is 22 pieces of candy to start with. Okay, so there's the answer. So we've declared a variable, written an equation, solved the equation, and then kind of written the solution in the context of the problem. So we know that 22 pieces of candy is how many she started with. Okay, let's take a look at example number 3, and then we'll do some problems from the assignment. Carlos spent half of his weekly allowance buying pizza. Half of his weekly allowance. To earn more money, his parents let him clean the windows in the house for $9. So he got paid $9 for cleaning the windows. And he ended up with $12. It says, what was his weekly allowance? So this is what we're trying to find. We're trying to figure out what his weekly allowance was. So what variable do you want to use and what will it represent? So A for allowance. Okay. Now let's represent what happened in the situation with an equation. He spent half of his weekly allowance buying pizza. So he started off with his allowance, and the first thing he did is he spent half of it. So he got rid of half of it, so we just divide that by 2. That's how much would be left after he spent half of it. Then his parents let him clean the windows on the house for $9. So they're going to pay him $9. That's going to increase the amount of money he has by 9. So we're going to add 9, and then that would equal 12. Again, this right here, this is the biggest part of what we're learning how to do today, is being able to translate what happened in a problem and put it into an equation. So let's go ahead and solve this. So I'm going to change colors again. I'm going to subtract 9, so I get A over 2 equals 3, and then we're going to times both sides by 2, so cancel there, so we get A equals 6. Now that's the answer to the equation, but let's make sure we answer the question. What was his weekly allowance? So we're going to say $6 weekly allowance. And now we've answered the question completely. We've declared a variable. We know what the variable in the problem represents. We wrote an equation that represents what happened in the situation. We solved that, and we figured out A equals 6, and A reminds us that that stands for allowance. So his allowance is $6 a week. And if you think about it, we could actually check this. If he spent half of that, he'd only have $3 left. And then if you add 9 to that $3, we would get 12. So we're in good shape there. Okay. All right. So if you can show your work that way, that's great. So again, we want to declare a variable, write an equation, and then show the solution. Now these are on your assignment, but they're not going to have these next to them. So let's read the problem. 239 students went on a field trip. 5 buses were filled with students, but 4 had to travel in a car. So they filled up 5 buses. 4 had to travel in a car. How many students were on each bus? How many students were on each bus? All right, let's see. So we could say B equals students on each bus. We could say S equals students on a bus. We could say X equals students on a bus. Any one of those choices would be just fine. Now here's what happened. Those 239 students went out in front of the school. They got on 5 different buses. So 5 different buses. We packed the kids on there. There were 4 kids left over. They had to travel in a car, and altogether that means there's 239 students. So 5 times the number of students on a bus plus 4 is going to be equal to 239. So we've got the number of students on buses plus the number of students in cars should equal 239 altogether. Now you could do something like this. You could say there are 239. They fill up 5 buses. So we put B students on each bus, and then the 4 that are left over right there. Those are really the 2 ways that I'd like you to do this problem. If you start using numbers that are not in here yet, like 235 is going to come up in just a minute and things like that. If you're trying to solve parts of this in your head, please don't. Please represent what happened in the problem. We have 5 buses full of students, 4 students in cars, and then there are 239 students altogether. Now whether you solve this one or this one, it doesn't make any difference. We're going to end up with the same answer. But again, we've declared our variable. We've got the equation that represents the problem, and now we're going to go through and solve. So we end up with 5b equals 235. We're going to solve that one-step equation by dividing by 5, so we get b equals, and then if we have to do a little bit of work off to the side, that's totally okay. 5 into 235 goes into 24 times. 35 left over goes in 7 times, so b equals 47. So this is the answer to the equation, but now we want the solution, the answer to the question, right? How many students were on each bus? So 47 students on each bus. So there's the answer to the problem, the answer to the question. But again, the keys here are that you figure out what variable you're going to use. This is really important right here, writing down an equation that represents the situation and then solving it and then kind of writing the answer in the context of the problem. Okay, let's take a look at number 10. How old am I if 300 reduced by 5 times my age is 80? Now there are a couple words here that we want to catch on to. There are definitely some numbers here, but reduced and is. And times, I guess that one's important too. So how old am I? So what we were looking for is the age. So we're going to say A is age. And then we take 300. And if we take 300 and we reduce it by something, we're making it smaller. So we're going to subtract. We're going to reduce it by 5 times my age. So 5 times my age. 5 times, A represents age. And then is means equals. If we do 3 times 4 is 12, is means equal, okay? So if we ever see an is, we know that's part of an equation, so that's going to be is 80. Again, that right there represents what happened in the problem. Very short sentence, but now we've got an algebraic equation to solve. So we're going to subtract 300. Let's see, negative 5a equals, let's see, this is negative 220. 80 minus 320, or 300 is negative 220. Divide by negative 5. Let's see, cancel those. So we get A equals negative divided by negative. That's good. And then 5 goes into 24 times. This is actually 44 if you figure that out. Okay, so we've got our equation, we've got our answer to the problem, and then the answer to the question here is 44 years old. And there we go. All right, writing down that equation from the problem, that's the most important thing. Okay, let's take a look at number 13 here. On Tuesday, Chandler bought 4 pairs of crazy socks. On Wednesday, half of all his socks were eaten by wild moths. On Thursday, there were only 11 pairs of crazy socks left. How many pairs of socks did Chandler have on Monday? How many did he have on Monday? So let's do, well, let's see, we could do S for socks. We could do M for Monday. We could say X equals number of socks on Monday. Doesn't really matter. Okay, so he had some on Monday. I'm going to use an M. On Tuesday, he bought 4 pairs of crazy socks. So we're going to add 4 pairs to his collection of socks. On Wednesday, half of all his socks were eaten by wild moths. So here's how many socks he had on Tuesday night, and on Wednesday, half of them got eaten. So the way we make half of them go away is we divide it by 2. That would be half as many as there were before. And then it says on Thursday, there were only 11 pairs of crazy socks left. So that means there is 11 pairs left, okay? So that would equal 11. So there's our variable, M for Monday. There's our equation. Now we just solve that equation. So we're going to times both sides by 2. We're going to get M plus 4 equals 22. And then we're going to subtract 4 from both sides. So we're going to get M equals 18. So that's the answer to the equation. What's the answer to the problem? How many pairs of socks did he have on Monday? 18 pairs on Monday. 18 pairs on Monday. There's the answer to the problem. Again, what we're really looking for here is being able to write that that equation right here. But let's just, on this one, let's double check and make sure. Let's see, on Tuesday Chandler bought 4 pairs of socks. So if he started out with 18 and he added 4 to that, he would have 22 pairs of socks on Monday, or on Tuesday. On Wednesday, half of his socks were eaten by wild moths. So if we take half of them away, that would be 11. And on Thursday, there were 11 pairs. So this checks out. We got the right answer. All right, again, focus on taking the information and then writing an equation. That's the important part. Not just getting the answer, but being able to write the equation. I've run into a lot of students, you know, even in college classes where they really struggle with something like this. So if we learn how to do it now, you're going to be much better off in the long run. All right, good luck.